Hello, everyone, and welcome to today's presentation. I'm Tammy Diedrich, the Managing Editor of IBM Systems Magazine, and I'm the moderator for this event. Today's webinar is sponsored by Optica Technologies and is titled, Modern Mainframes Have No ESCON. What do we do? Our featured speakers today are Ray Newsom, Sean Seitz, and Michael Daly. Ray Newsom is the IBM System Z Hardware Subsystem Strategy Leader and is responsible for the tactical strategy focused on the current and future System Z platform requirements with respect to the hardware subsystems of I/O, networking, coupling, and cryptography. His experience includes several technical and management roles in the System Z Hardware Development Organization, along with his current role in the System Z brand organization. Sean Seitz is the Vice President of Technical Services at Optica Technologies and is responsible for technical sales, services delivery, and product support worldwide. Sean's mainframe experience exceeds 25 years and includes business management and executive positions in technical sales and support, product management, business development, and consulting services with McData Corporation, Fujitsu Technologies, and Amdahl Corporation prior to joining Optica. Michael Daly is the Chief Operating Officer and Vice President of Worldwide Sales for Optica and is responsible for global sales and business development. Mike began his career at IBM and during his 13 years there held a variety of executive positions in sales, product management, product marketing, and strategy. He also served as Director of Sales Operations for IBM America's multi-billion-dollar server group. Today, our presenters will review the most current System Z ESCON roadmap and connectivity landscape and share how Optica's Prism makes the transition easy. Just to note, too, that the slides will be available to you in the follow-up materials. Following the presentation, we'll have a brief Q&A period, so please feel free to enter your questions in the question panel on your screen anytime during the presentation. Now, without further ado, thanks again for joining us today. And Sean, I'll turn the presentation over to you.
Thank you very much, Tammy. This is Sean Seitz with Optica Technologies. On behalf of the Optica team that's on the webinar today and Ray Newsom of IBM, we'd like to thank IBM Systems Magazine for hosting today. I'd also like to thank everyone who's in participation. We know your time is valuable and we appreciate you joining us. I'd like to get started by just reviewing quickly the agenda for today's presentation. I would like to give a quick background on Optica and our relationship with IBM. At that point, I'm going to turn it over to Ray Newsom, who's going to review the IBM Systems I/O strategy. And then I'll take back over the presentation and dig into the Prism solution itself that we're here to talk about today. We'll review a little bit more information and interesting facts on the ESCON transition. I'll talk specifically, of course, about the Prism solution itself, the applications for Prism. I'll give you some very specific customer examples and the benefits to those customers. And then we'll talk about how do I plan for Prism? How do I actually go about the planning and implementation of the product? Okay, and then we'll leave some time at the end for Q&A. Optica has been in business for more than 45 years. And of the 45 years, 25 of those we've been dedicated and focused exclusively on the mainframe segment. So Optica's resources are all very mainframe savvy. We've all been around for a long time, and we focused on mainframe. So we have some very good mainframe skills, and we understand the challenges of the mainframe customer. Based on our experience and our partnership with IBM, we have a very unique position in the marketplace in terms of our partnership with IBM. We're the exclusive provider of conversion solutions to the IBM System Z brand, and we have been since 2002. You may remember the previous transition for I/O back in the early 2000s when bus and tag parallel channels were actually eliminated from the mainframe. It was at that point that Optica partnered with System Z to provide an ESCON to parallel converter to replace IBM's own converter known as the 9034. And you may remember the 9034, affectionately known as the muffler, because it resembled an actual Midas muffler in that it was rounded and had that muffler shape. So Optica's FXBT, as pictured here in the slide, is actually the converter solution that replaced the IBM solution when it was discontinued. So since that time, we've placed in excess of 24,000 of those converters globally. So you may be very familiar with that yourself. You may have those installed in your data center still today. We actually still get requests for that product occasionally, believe it or not, even though it's been officially withdrawn from marketing. So it's that exclusive relationship with IBM System Z that has progressed to a point where we are actually producing the next generation of converter, known as Prism, FICON to ESCON converter solution, that IBM System Z customers are leveraging today. The product itself, Prism, has been available in the market for more than 6 years and has a very large installed base globally already across all market segments. Large customers, small customers, including business class all the way up through the largest enterprise class customers. At this point, I'd like to ask Ray Newsom to join us and cover the System Z I/O strategy specifically.
Thank you, Sean. For those who are unaware, over the last couple of years, we have put out some statements of directions in our hardware announcements stating our intention to stop supporting ESCON channels. And with the announcement last year of the EC12 and the recent announcement of the BC12, these are the first two System Z platforms that do not natively support ESCON channels. The one point I'd like to make here is there is no RPQ or exceptions available for either of these two. The code has been removed from the driver. So what we're really trying to do with this strategy is enable a seamless transition for our customers that want to upgrade to the EC12 or the BC12, but still require ESCON or bus and tag access to those particular devices. And then, of course, where and when appropriate, customers should take a look at whether or not they can migrate some of those old devices to FICON, high-performance FICON, FCP, or IP-connected devices. And as Sean had mentioned, Prism and Optica are extremely strategic to our System Z I/O strategy for the elimination of these ESCON channels and are definitely the way forward for our customers that still require ESCON and bus and tag connectivity. And for those unaware, for the last 4 years or so, we have had a GTS solution available that you see here at the bottom of the slide. That's an ESCON to FICON migration solution where they can help design and deliver the solution to all of our customers. With that, I will turn it back over to Sean.
Thank you, Ray. Appreciate that. There's a few interesting ESCON tidbits that we wanted to chat about here. Obviously, as Ray mentioned, ESCON will no longer be supported on the newest System Z platforms or any future platform. Oftentimes, customers overlook the fact that there are multiple chiplet types, ESCON chiplet types, that are genned on the mainframe. And here we list the 4 chiplet types. Obviously, CNC or native ESCON is the most prevalent, and certainly if you're on this call and you're interested in this webinar, you most likely are running native ESCON channels today, chiplet type CNC. But there are 3 other types. The next 2 in the list here, CVC and CBY, those chiplet types actually represent a converted ESCON channel type. And that means if you have those chiplet types genned on your mainframe today, that means that you're running currently an ESCON to bus and tag converter. That's a converted mode ESCON protocol. That means you have a bus and tag device on the other end of that channel. Okay, so the CVC represents a block multiplexer type channel, and the CBY represents a byte multiplexer type channel. Okay, and then finally, often overlooked is the CTC channel. So clearly, if you're running ESCON channel to channel today and you migrate to the newest System Z platform, most of the time you're going to be able to migrate those CTC applications to FICON CTC. Okay? Now, it might be interesting further to understand that the majority of System Z customers today still have one of these chiplet types, at least one of these chiplet types, genned on their mainframe. In fact, from our experience, we think that roughly 75 to 80% of Z customers still have ESCON chiplets genned. Now, whether or not they're using those actively is another question, but certainly our guess would be that somewhere in the neighborhood of 50% of every System Z customer is still utilizing ESCON chiplets of some kind. So you might find that interesting. You're not alone if you wondered how the rest of the customer base has progressed with their migrations. You're certainly not alone if you're still managing ESCON devices or even bus and tag devices for that matter. I would say of the 50% of System Z customers that have ESCON chiplets that are active, there's probably 30% of those that still have bus and tag devices. So you may find that hard to believe, but statistically speaking, from our installed base and our customer base, I would say those are relatively accurate figures. So many bus and tag devices that are still important to your business may still be in use today. So don't feel like you're standing alone if you have ESCON or even bus and tag devices still in use. When we talk about the transition away from ESCON, folks, you got to think about it really in three different categories. Obviously, we've been talking about mainframe I/O and the lack of ESCON chiplets on the newest platform. But there's also a layer of switching that you guys are very familiar with, I'm sure. There's also an extended distance category. So if you're running ESCON directors today to switch your ESCON environment, obviously those are going to have to go away when you migrate to the EC or the BC12 environment, okay? Actually, the ESCON director Model 3 and Model 5 have been announced as end of support effective March 31st of 2014, in case you were not aware of that. That's in North America. So again, if you're running a Model 3 or Model 5 ESCON director, official end of support from IBM is March 31st of 2014. Interestingly, in every other geography of the world, ESCON directors are already in end of support status. Okay, so any ESCON director switching you're doing today, that's going to be migrated over to your FICON switch network if you have a FICON switch network, and in combination with Prism to support your ESCON and bus and tag devices. Okay, and then finally in the extended distance category, really what we're talking about here is IP channel extension, and a large majority of the marketplace is handled by the old CNT product known as USDX. There's a very large installed base of USDX ESCON channel extension gear. That gear is end of support status as well. Most models of USDX. So Brocade's newer solution, which is the 7800, will actually extend the FICON channel over IP. So don't forget about your distance solutions, and moving to the next mainframe platform and your requirement to migrate forward to a FICON channel extension-based solution if you're running ESCON today. Okay, so as we've heard here from Ray, there is a very hard stop here on the use of ESCON with the newest platforms. There is no side door. There is no RPQ. This is for real. There is no more ESCON available starting with the EC and BC12 moving forward, okay? Yet, we recognize that a large percentage of customers still have a requirement for some of the stable ESCON and bus and tag devices and applications that have been running for a very long time. So essentially, we're here to talk about how to move those forward. And if you have those devices that are considered legacy ESCON or bus and tag based devices and applications, the way forward is to migrate those onto the EC and BC12 using the Optica Prism solution. And we're going to talk to you about how you can do that in a very efficient manner without impacting your operations and not impacting those devices and applications that they support. Okay, so let's talk a little bit about the Prism solution itself. Now, if you remember the previous generation of product, the ESCON to bus and tag converter that Optica called the FXBT, that was a single channel in, single channel out. The Prism solution is an appliance-based solution, and therefore it's multi-channel. So it's a little different when comparing it to the previous generation of converter. The Prism FICON to ESCON converter can handle up to 2 FICON channels from the mainframe and produce up to 8 ESCON channels out to the devices. Okay, so you can see here the available configurations are 1 to 2, 1 to 4, or 2 to 8. Let me talk about the 1x2 Prism configuration. That represents 1 FICON in, 2 ESCON out. That's a brand new solution that Optica has just announced, and it will be GA, generally available in conjunction with the new BC mainframe. So this has been announced in North America. The 1x2 is available through the business partners in North America. Outside of North America, it's available based on a special bid basis or special request basis. So the 1x2 is brand new to help BC customers specifically with a lower entry point for smaller requirements. Okay, so that'll support 1 or 2 ESCON or bus and tag devices. And then again, 1x4 and 2x8, 2x8 representing the largest configuration within a single Prism appliance. The Prism solution will ship with both long-wave and short-wave FICON optics, so we can accommodate either infrastructure that you may have. The product itself has also been tested extensively in IBM's vendor qualification lab. So if you're familiar with what IBM calls System Assurance Kernel, or SAK, we have invested in that testing and certification, which essentially ensures that any ESCON device can be supported behind Prism. Okay, so as long as the device itself follows ESCON protocol, it will be no problem to attach it to Prism and run it on the new System Z. We also have extensive testing relationships with Brocade and Cisco in terms of FICON switching and FICON extension. So there is no interoperability issue really with Cisco or Brocade products in the FICON fabric. From a maintenance and support perspective, it's worth noting that the Prism itself is supported by Optica, so it is Optica branded support and maintenance on an ongoing basis. However, we do partner with IBM, and IBM serves as our global hands and feet, and essentially our on-site presence. If there is any issue requiring hardware swap or hardware replacement, Optica leverages IBM for that support. So the same SSR or the same SCE that you would leverage for your mainframe support is likely going to be the resource that would come on site to support Prism for you. Okay, this is a front and rear view of Prism itself. And as you can see in the lower picture, the rear view here, the FICON ports are represented in the box on the upper left. Those ports are LC duplex connectors, so that's the FICON side. Again, 1 or 2 FICON inbound ports from the mainframe are accepted here with LC duplex. And just to the right of that is the ESCON ports. Those are natively MTRJ connectors. Okay, so depending on the model of Prism, you'll utilize 2, 4, or 8 of those ESCON ports, okay, on the outbound side. Prism does have dual redundant power supplies, as you can see on the right-hand side, okay, and it also has 2 network interface ports just below the FICON ports there on the left side. And those NIC interfaces are essentially used for 2 purposes. One is for the customer to manage the Prism unit, so they'll attach Prism to their corporate network, and they can IP into Prism, into the web-based GUI, to manage, monitor, and configure Prism. Okay? The other reason for the network interface is for Optica's remote access into the unit from a maintenance and support perspective. Okay? So that access remotely gives us the ability to efficiently support the product, troubleshoot any issues, assist customers, etc. Okay, so we often get the question when we're talking to customers about Prism, how in the world can you make an ESCON or a bus and tag device talk to a FICON channel? That's impossible, right? How can you do that? Well, it's actually not black magic. It actually works, and it works well. Let me give you a little bit of an overview on how we do this. First and foremost, understand that Prism is actually not defined in your mainframe gen. So it's not a device that you actually code in IOCDS. Okay, so the Prism itself is actually transparent to the mainframe. What you do code, however, is you obviously code your FICON chipids that are accessing Prism. You code those as native FICON or chipid type FC. Now I want to point out that this is not an FCV channel. If you remember the previous FICON bridge technology, that leveraged the FCV chipid type. That was a technology that allowed a converted FICON channel to access a bridge card that was housed in the Model 5 ESCON director, if you remember that. That technology has since been discontinued by IBM, and it was somewhat of a FICON conversion technology. But this is very different. Prism attaches to a native FC chipid type, and the value of that is it allows you to share that chipid. So you do not have to dedicate an FC or a FICON chipid to a single ESCON device or, God forbid, a single bus and tag device. You can actually share that with your native FICON devices. Okay? And then from a device perspective, depending on the device type or the model number, you may code the device, or the control unit, I should say, as itself, or you may have to use no check. And the difference being, if the device, the control unit, is capable of FICON, and let's use 3590 tape as an example. 3590 can be an ESCON native device, or it can be a FICON native device. Given that it's FICON capable, you can code it in your gen as itself. So you can code it as control unit type 3590, and HCD will not complain. It will allow that definition. On the other hand, if we're attaching a 3480 tape drive, that is not FICON capable, and therefore HCD would not like the fact that you're trying to attach it to a FICON channel. Therefore, you must code that CU as no check, okay? And that works perfectly fine. Okay, and then all normal ESCON rules apply for your control units and devices. For example, if you're running a control unit, an ESCON control unit that's capable of a maximum of 16 LPARs, then that remains the case when you're attaching it through Prism. That does not change. So as a general rule, all your standard ESCON rules will remain intact when you're attaching to Prism. Okay? I mentioned that Prism itself is transparent to the mainframe gen. The way that's possible is because we create a configuration file that we call Prism Configuration Dataset, or the PCDS. That represents a configuration file that's created that is loaded onto Prism to create that connectivity that's required. So from a very high level, from a methodology perspective, the way that magic works is that Prism utilizes the 2-digit FICON CU add, with the left digit representing the ESCON port number on the back of Prism, which is going to be 0 through 7, and the right digit representing the native ESCON CU add that's already being used. So with that high-level methodology, that configuration file allows the proper routing of FICON logical path to ESCON logical path. Okay. If you have any questions that are more specific about configuration or more detailed or technical, we'll be happy to answer them at the end or offline after the presentation. Okay, this is probably a familiar looking diagram to you if you've taken the time to join the webcast today. You're likely managing two different infrastructures on System Z. You probably have FICON and ESCON today. You may have FICON switching. You may also be running ESCON switching at the same time, right? You may have completely local environments. You may have an extended environment or a distance factor here where you're running channel extension out to a remote data center. That may be the case for FICON or ESCON or both. So this is probably a familiar looking diagram where you're managing native FICON connectivity, you're managing ESCON connectivity, and maybe even bus and tag connectivity through an existing ESCON to bus tag converter. By contrast, this view is after Prism is implemented. So As an example, you've migrated forward to the new EC12 mainframe platform, which does not support ESCON. This is a view of what your consolidated infrastructure will look like. You've been able to remove your ESCON directors and retire those. You get to take advantage of the maintenance savings. You get to take advantage of the increased floor space after removing those ESCON directors. Your utility bill is going to decrease when you don't have to power those ESCON directors. So this is the consolidated view. And I might point out that, and I'm going to back up for you here one slide, and I'd like you to look at the lower right-hand part of this diagram. Again, this is the previous view where you're managing both infrastructures. You'll notice that there's some native ESCON tape here, as well as some parallel printers being converted today. So again, moving forward to the consolidated view, you'll notice those applications and devices remain behind Prism. So we're going to talk to you about how you can leverage the Prism solution to maintain those important applications that you have. And as Ray mentioned, you have every opportunity to migrate those devices to native FICON. And where that makes sense, we hope that you take advantage of that. Where you can take advantage of performance, you can take advantage of feature function, and the cost benefit is justified to migrate forward to FICON, native FICON device connectivity. However, there's a set of applications that you may have where that cost justification is not there. You have a stable, mission-critical application that may be running on an ESCON device or even a bus and tag device, and it just does not make sense to migrate that forward. Or there may not be a native FICON interface option for that particular device. In any case, you can move those forward with Prism seamlessly without impacting operations, without impacting the device. Sometimes the device itself will have a configuration on it. Prism can support that device without impacting the device configuration or the application. Okay, let me just talk to you a little bit more specifically about bus and tag support. Some of you on today's webcast may be running bus and tag devices. Not to worry if so. There's a seamless way to migrate those bus and tag devices and actually attach them to FICON. We use what we call our ESBT module as pictured here. Now you may ask, why can't I use my existing ESCON to bus and tag converter? And that's an excellent question. We get it all the time. It would be nice if you could leverage that existing converter. However, if you're moving those bus and tag devices forward to the System Z, EC12 or BC12, you have to invest in Prism, and you also need what we call our ESBT module. The Prism itself produces a native ESCON channel, and that's that chipped type CNC. Your existing converter, if you have a bus and tag device, that existing converter attaches to a CVC channel. That CVC channel is a converted mode ESCON channel. So this is very different technology. That existing converter cannot plug into Prism and support a bus and tag device, and that's why you have to replace it. Simple upgrade to the ESBT module is shown here. Now, one other point that I want to make. We've talked about the ability to migrate bus and tag and ESCON devices to Prism. There is one exception that cannot be supported on the newest mainframes, and that is byte mode bus and tag devices. Now, a very small percentage of existing bus and tag devices are actually running in byte mode, but that is the only device type that cannot be supported on the new platform from IBM. Okay, so for example, some 3745 communications controllers run in byte mode. Those will not be supported behind Prism and ESBT, but we've run into very few of those. Most of the time, these devices are running in block mode. The reason, or I should say the way that you can tell, is if your device is currently attached to a CBY chipped type. That CBY chipped type designates byte mode device. And so if you have that situation, you're going to look at how you can either migrate that to a block mode operation or migrate it to another technology or connectivity method, because a byte mode device cannot run on an EC or BC12. Okay? Okay, so this is representative of all of the topologies that are supported by Prism. So essentially, any topology that you're running today, you can introduce Prism into without a problem. In the upper left, this is the simple direct connect methodology. This is without FICON switching. Many BC customers are in this mode where you're not running a FICON switch of any kind. Prism can connect directly to the chiplet without a switch in the middle. That's not a problem at all. Just to the right is representative of the switched infrastructure. This is the most common, and Prism will attach to a single FICON director or a FICON fabric locally without an issue. Lower left represents what we consider a campus or metro topology, which is known as an inter-switch link or ISL between FICON switches. Again, we see this commonly in the metro area or across a campus, but Prism drops seamlessly into a cascaded or ISL environment. And then finally, the IP extended topology. And this is probably a relatively small set of Systems E customers that leverage IP channel extension, but Prism is a very nice complement to this in that a lot of folks are running ESCON tape or ESCON or even bus and tag print in a remote data center, and it does not make sense to migrate those to FICON. And so Prism can be placed in the remote location behind the IP channel extension solution and support those devices remotely. Okay. The only caution that I'd mention is that both Brocade and Cisco offer IP channel extension solutions, and you have to make sure you check with them on what device types can actually be supported with native performance over distance. Okay. But Prism will drop into any topology that you're running currently. What device types are supported by Prism? As I mentioned before, with IBM's SAC certification, we say that essentially any device type can be supported without issue. The majority of the devices we support are tape. I would say roughly 75% of the device portfolio behind Prism today across hundreds of customers globally is going to be tape. But we connect to a whole lot of these other categories, whether it be communications gear, print. DASD or disk is relatively rare because most customers are investing in native FICON connectivity. However, we do have customers that are attaching ESCON DASD to Prism. Okay, and then in the lower right is the miscellaneous section and what we call really the cats and dogs. So this is some of the more unique device types that we're attaching to behind Prism without a problem. Okay, so how do I determine if there's a need? And this might seem like a silly question because you might be thinking, well, of course I know if I have ESCON or bus and tag devices and whether I'm going to need Prism. What we've discovered is that a lot of times customers actually have to do some analysis on their gen to really determine what's in use and what isn't. Either discovering that some older devices are actually still being used or used occasionally that they didn't think were, or even thinking that they don't have bus and tag devices because they have all ESCON chiplets on the mainframe. Obviously, if they're running a converter today, they may have or they will have a bus and tag device behind that converter. So be aware of the various levels we talked about before that you have to address, not only the mainframe I/O transition, but the switching transition and the distance transition, and particularly whether or not you're running any bus and tag that's going to require the ESBT module. Okay, let's talk about a couple very specific customer examples. I've highlighted two examples here in today's presentation. The first was a state government account, and this account had older Systems E technology, N-2, and they were challenged with modernizing on the mainframe and also trying to figure out how to reconcile their device portfolio, which devices to migrate to native FICON, which to maintain behind Prism when they migrated to the newer Systems E technology. The unique part about this particular case was the amount of ESCON they were managing. And you can see here, this is the before picture, or their original ESCON environment. You can see with a single KEC, they had a large amount of ESCON devices and applications that remain. And they had to decide which of these to migrate forward and which to try to migrate to a native FICON connectivity. We consulted with the customer and developed a design represented here. You can see we introduced 10 Prism units in this particular case, and all of their ESCON devices, they actually had a couple of bus and tag devices there too in the lower middle part, STK4480 tape, but all of their device portfolio migrated forward when they went to the new mainframe technology onto Prism seamlessly. And this was unique in that it had a wide range. They had a wide range of device types that they required to keep, from print to tape to DASD and 3174 gear. The second customer example was a large financial account, and this was a little different in that they had multiple data centers. They had 3 data centers running System Z technology, and they were challenged similarly with updating their mainframe technology to EC12 and trying to figure out how to reconcile their devices, primarily tape. And as you'll see here in the Prism design diagram, this is the design with the Prism introduced. You can see that they accessed these 9480 and 9490 tape drives not only from the primary site but also from 2 other remote data centers, Texas and Virginia, where they were leveraging IP channel extension into the main site to attach to the same types of tape drives. In this particular case, STK tape drives. Okay, so the customer was able to maintain these ESCON drives that were important for compliance and for data sharing with partners, as well as migrate to the newest technology, in this case to 6 EC12s in their main data center. So this was a representative of a very large case, a very large enterprise-level customer that leveraged Prism for legacy tape access. So in summary, across both of these customers, they were able to seamlessly migrate their legacy devices. And I want to emphasize that when configured and implemented, Prism will allow you to move those devices forward without changing anything. You don't have to change anything operationally. You don't have to change anything on the application level or at the hardware level. So as long as Prism is configured properly for the actual connectivity and access, nothing has to change on the device side. So it's a very seamless migration with no impact to those devices and applications. Okay, in terms of when to plan for Prism and when to plan to implement Prism, we have a very simple recommendation and methodology that we like to use. When you're planning your new mainframe or that upgrade to a Z EC12 or BC12, you certainly need to be considering your Prism requirements as well, okay? The best practice is to actually implement Prism when you can on the existing platform, and roughly as a rule of thumb 30 days in advance of your upgrade to the mainframe. This will allow you to implement Prism, make sure that the migration to Prism goes seamlessly and goes well. Those devices are validated in terms of end-to-end connectivity, and you have everything set up in your existing environment relative to Prism prior to migrating to the new mainframe. That simplifies your cutover to the mainframe when that day comes, and it eliminates or reduces your risk when you separate those 2 projects. I would say most of the time our customers are able to do that, to implement Prism on their existing platform, but not always. So it's not required, it's not mandatory. When you have time in your planning process to do so, it is recommended that you do it that way. Okay, if you have a requirement for Prism, we have a very simple web-based form that's hosted on our website, and the link is shown here at the bottom of this slide. And what we ask you to do is actually visit our website and populate this form if you have a requirement or think you have a requirement for Prism. This form asks a handful of questions about your environment and allows us to, based on your feedback, tell you what we recommend in terms of a Prism solution. And then once you validate that connectivity that we show you in a draft design, then we can go ahead and get it quoted for you through any number of channels. So this is the way to begin your process for identifying what your PRISM requirement will be. Again, there's lots of variables from local connectivity, remote connectivity, how many KECs you have, how many LPARs per KEC. Obviously, understanding your device portfolio is important and how many physical interfaces that you have. But this is really kind of a snapshot, these 5 questions of the most important variables that we like to collect information on. There's a few more than these in the form itself, but we ask you to populate that form, submit it. It comes right to me and my team, and from there we'll create a draft design and recommended solution for you and show you what will support your requirement. Okay? Okay, so that actually concludes the overview today, and I wanted to mention that, again, that we appreciate your time in attending, and for attending today, we're going to actually have a drawing for all registered attendees. So on September 15th, your name will be in the hat as a registered attendee today for a chance to win an Apple iPad. So we'll announce that drawing winner on the 15th of September. And again, good luck there. We appreciate your time in attending today, certainly. And that brings us to the end of the presentation. And at this point, I'd like to turn it back over to Tammy, our moderator, and she'll be opening it up for questions.
Great. Thank you so much. So we'll take a few minutes to answer some questions now. Again, if you have a question, you can use the Q&A panel on the right side of your screen to send it in, and we will get to as many as possible. If for some reason we don't get to your question, we will get back to you via email. All right. So the first question, how do I get PRISM? Who do I buy it from?
Okay, so this is Sean. That's a very good question. And Mike Daly is on the line with us here, and Mike is responsible for Optica's global sales process. So I'm going to ask Mike to address that question, if you could, Mike. Mike, do we have you? Okay, Mike may be...
No, you got me now. Sorry.
There's Mike. Go ahead, Mike.
I think I was double muted there. So this is Mike Daly. Thanks, Sean. We have a variety of ways for you to receive PRISM, as I think you and both Ray pointed out. We have a relationship with IBM GTS, and typically when there's an IBM direct relationship around the mainframe, we'll package PRISM through GTS as part of the proposal process. So IBM GTS is one channel that's worked very well for us. And then typically we'll work with your IBM partner, so your System Z partner. If you're a business class customer or an enterprise customer who's working with one of IBM's major System Z partners around the world, we certainly support that relationship. And so, for example, in the United States, a mainline or a Sirius would typically be a partner that we work with. In some countries around the world, we'll use our IBM relationship and our distribution relationship with a company called Annixter International, and generally speaking, that's worked very, very well for us.
Great, thank you. How do I get additional information about how PRISM is configured?
Okay, that's another good question. If you have interest in understanding a little bit more deeply how PRISM is configured and how it fits into the mainframe gen, we have a 2-page document that we call Theory of Operation that provides some detailed examples and a little bit deeper explanation. So what I would suggest, if you have interest in seeing that document, you can drop me an email. You can see my email address here right on the slide. Drop me an email, and we will make sure that we get you that document. We'd also be happy to connect with you directly by phone and answer any questions along those lines that you may have.
Great. All right. Can IBM provide the maintenance and support for PRISM?
So the maintenance for the PRISM product is provided by Optica. So the agreement for your maintenance on the unit is directly with Optica. However, Optica does subcontract with IBM to provide local on-site coverage. So anywhere on the globe, as long as we have a local transaction agreement executed with IBM, then Optica can actually dispatch an IBM SSR to go on site for any hardware replacement activities or anything that requires on-site presence in terms of support of Prism. So again, in summary, the maintenance agreement is direct with Optica, but Optica subcontracts back to IBM globally for our hands and feet.
Okay, I have a couple of questions about time. One is, what's the lead time from order receipt to delivery? And the other one is about how long the outage will be if you choose to implement Prism.
Okay, very good questions. Let me take those one at a time. Let me take the second one first. So what length of outage is required for implementation of Prism? So as I mentioned before, there's a Prism configuration file that actually is loaded onto the Prism unit. The creation of that file is, of course, offline. It's an offline process that Optica will support you with on the original implementation. So every time a customer acquires the Prism solution, with the hardware comes the Optica implementation services. And we will consult with the customer to create the detailed port-level end-to-end design. We will consult with the customer on how to update their gen to support Prism, and we will actually create the Prism configuration file that's loaded onto Prism. Now, all those things and all that process is done, of course, offline. So the Prism is physically installed in the customer location. It's powered and set up with the Prism configuration file resident on the Prism. And then in terms of an outage, it's really just a matter of the time required to move your channel cables and bring those chipids online and the devices online through Prism. So that would be handled in a typical maintenance window in terms of actually migrating the Prism into the production environment. And I guess to sort of expand on that, I'm going to ask Russ Pustai, who's on the line with us here. Russ is a product engineer who's implemented Prism all over the world, and I'm going to ask Russ if he has anything to add to that answer that I just gave.
Yes, it really depends on the customer's environment. A lot of customers really take no outage at all. They will implement your ILCDS changes dynamically and move the devices, such as tape drives and whatever, that they can take offline from their ESCON channels and move them right over to Prism. In fact, in some cases, they can be defined on both FICON and ESCON. So it really depends on the environment and the device, whether or not it can be moved during the day or it has to have an outage. You know, like a communications controller would have to be more than likely done on a weekend outage type. But the time is very, very minimal, usually just the amount of time to activate the gen, move the cables, and bring things online.
Okay, thanks, Russ. I believe, Tammy, there was the first part of that question was relative to lead time, and generally speaking, from Optica receipt of order, we can ship a Prism within 2 to 3 weeks. Sometimes much more quickly than that, but 2 to 3 weeks is a standard lead time for shipment of the Prism unit from receipt of order.
Okay, great. Do you need an ESBT for every parallel device, or in other words, can an ESBT support more than one device?
Great question. So just like today, if you have a bus and tag device and it's running behind an existing ESCON converter, you can daisy chain multiple bus and tag devices behind that converter, and I'm assuming that's the genesis of the question. When you move to Prism and ESBT, the short answer is yes, you can daisy chain most devices, but as part of our design assessment is there are certain device types that cannot be daisy chained behind ESBT because of their architecture. they will not perform properly. So that's part of our design assessment. We can tell you, based on what you have, whether or not your devices can be daisy-chained behind Prism and ESBT, just like they are today.
Okay, and does ESBT support Luminex or Polaris 3174 SNA gateway devices?
Yes. In fact, we have customers today that are running those devices behind Prism and ESBT, so not a problem.
All right. How does the number of LPARs affect the design?
Okay. Russ, I'm going to ask you to address that question, if you could, please. The very high-level answer is that there's an access analysis that has to be performed, and I'm going to ask Russ to address that, if you don't mind, Russ.
Yeah, no problem. Typically the number of LPARs doesn't really affect the design any more than it normally would. You would assume that the devices that you're connecting are supporting the number of LPARs that the device can support, so you wouldn't be adding additional LPARs. So it really doesn't affect it that much. One thing also to keep in mind with Prism is that you can span channel subsystems with your FICON channels, so the number of LPARs can, reach the number of LPARs that the device can support. Maybe in some cases even 60, 70, or even in some cases 100 LPARs. But that's all relevant to what the device can support.
Okay, another question here. If all of the ESCON devices are getting retired or expired, why would a customer need to go to Prism? Because it sounds like the future depends on the FICON.
That's exactly correct. In fact, if you are able to migrate all devices to native FICON connectivity, that is an ideal scenario for you, and you should do so. In that case, Prism is not required, of course. You won't have any ESCON or bus and tag devices remaining that have to attach to the new mainframe. So if there's a cost justification for migrating to native FICON devices, absolutely that's the first priority. And if you're able to do so, and many customers have been able to, then Prism is absolutely not required.
All right. Do Optica have any other devices which improve network performance? Or how do I get those details, or who do I need to contact?
That would be probably a good idea to take offline. If you would like to contact me, my phone and email address is displayed here on the slide. I'd be happy to talk to you about that and answer those questions for you.
Sure, we can get back to that person too via email. So looking at the clock, I think we have time for one more question, squeeze one more in, and that is, can I implement Prism myself and manage those changes, the changes to the configuration myself, or am I going to need help with that? Excellent
last question. As I mentioned previously, when you invest in the Prism solution, 100% of the time, Optica will implement it for you originally. So it's required for us to basically consult with you on how it goes in, how to update your own mainframe gen, how to create that Prism configuration file with a tool set that we offer, that we use. So the original implementation of Prism is performed by Optica. Regardless of who it's purchased from, Optica delivers those implementation services globally. However, we also will do knowledge transfer as part of that engagement. And so ongoing management and maintenance and updates to the Prism can absolutely be managed by you, the customer. So we can do that knowledge transfer, that training on how to implement change, to update the configuration file if there's been a change in your environment on an ongoing basis. Absolutely, the product can be managed by you, the customer. Great. Thank you, gentlemen, for sharing all your expertise with us today.
Just a quick note that we will be sending out a link early next week to a recording of today's presentation to everyone who's on the call, as well as to everyone who registered for the event but for whatever reason couldn't make it. And there will be a link to the slides in that follow-up material. So that concludes our webinar today. I want to thank everyone for attending, and have a great day.